Learning objectives. In this chapter, the user would be learning about C# using libraries and the following in detail. Namespace system, input-output, multi-threading, networking and sockets, data handling, Windows forms, C# in web application, error handling.
Namespace systems. This lesson introduces you to C# namespaces. Understand what namespace is. Learn how to implement the using directive. Learn to use alias directive. Understand what namespace members. Namespaces are C# program elements designed to help you organize your programs. They also provide assistance in avoiding name clashes between two sets of code. Implementing namespaces in your own code is a good habit because it is likely to save you from problems later when you want to reuse some of your code. For example, if you created a class named console, you would need to put it into your own namespace to ensure that there wasn't any confusion about when the system.console class should be used or when your class should be used. Functionality provided by system namespace. The C# library system provides a list of different functionalities for namespaces, which are listed here. Commonly used value, mathematics, remote and local program invocation, application environment management, reference data types, events and event handlers, interfaces attributes processing exceptions, data type conversion, method parameter manipulation. Classes provided by system namespace. Along with different functionalities, namespaces in C# provide a list of classes. They are listed here. Access violation exception, array, argument null exception, attribute usage attribute, buffer, console, convert, delegate, exception, invalid cast exception. Interfaces provided by system namespace. A few interfaces provided by the namespace system in C# are listed here. Public interface clonable, public interface comparable, public interface comparable type, public interface convertible, public interface custom formatter, public interface disposable, public interface equitable type, public interface format provider. Namespaces. A namespace is designed for providing a way to keep one set of names separate from another. The class names declared in one namespace will not conflict with the same class names declared in another. Defining a namespace. Using keyword. Nested namespaces. Defining a namespace. A namespace definition begins with the keyword namespace followed by the namespace name as follows. To call the namespace-enabled version of either function or variable, prepend the namespace name as shown. Using keyword. The using keyword states that the program is using the names in the given namespace. For example, we are using the system namespace in our programs. The class console is defined there. We just write. We could have written the fully qualified name as by using namespace directive. This directive tells the compiler that the subsequent code is making use of names in the specified namespace. Nested namespace. An example of nested namespace is given here. Namespaces can be nested, where you can define one namespace inside another namespace as follows. You can access members of nested namespace by using the dot operator. Namespaces can hold other types as follows. Classes, structures, interfaces, enumerations, and delegates. Input, output. The input and output in C# is based on streams. A stream is an abstraction of a sequence of bytes, such as a file, an input-output device, an inter-process communication pipe, or a TCP/IP socket. Streams transfer data from one point to another point. Streams are also capable of manipulating the data. For example, they can compress or encrypt the data. In the .NET framework, the system.io namespaces contain types that enable reading and writing on data streams and files. C# I/O classes. The system.io namespace has various classes that are used for performing various operations with files, like creating and deleting files, reading from or writing to a file, closing a file, etc. The following table shows some commonly used non-abstract classes in the system.io namespace. The file stream class. The file stream class in the system.io namespace helps in reading from, writing to, and closing files. This class derives from the abstract class stream. You need to create a file stream object to create a new file or open an existing file. The syntax for creating a file stream object is as follows. Advanced file operations in C#. An example of simple file operation in C#. When the code is compiled and executed, it produces the following result. Reading from and writing into text files. The stream reader and stream writer classes are used for reading from and writing data to text files. These classes inherit from the abstract base class stream, which supports reading and writing bytes into a file stream. The following example illustrates a stream reader class. The stream reader class also inherits from the abstract base class text reader that represents a reader for reading series of characters. The following table describes some of the commonly used methods of the stream reader class. The following example illustrates a stream writer class. When the code is compiled and executed, it produces the following result. The following table describes some of the commonly used methods of the stream writer class. Multithreading. A thread is defined as the execution path of a program. Each thread defines a unique flow of control. If your application involves complicated and time-consuming operations, then it is often helpful to set different execution paths or threads, with each thread performing a particular job. Threads are lightweight processes. One common example of use of thread is the implementation of concurrent programming by modern-day operating systems. Use of threads saves wastage of CPU cycle and increases the efficiency of an application. However, this way the application can only perform one job at a time. To make it execute more than one task at a time, it could be divided into smaller threads. Thread lifecycle. The lifecycle of a thread starts when an object of the system.threading.thread class is created and ends when the thread is terminated or completes execution. The various states in the life cycle of a thread. The unstated state. It is a situation when the instance of the thread is created, but the start method has not been called. The ready state. It is a situation when the thread is ready to run and waiting CPU cycle. The not runnable state. A thread is not runnable when sleep method has been called, wait method has been called, blocked by I/O operations. The dead state. It is a situation when the thread has completed execution or has been aborted. The main thread. When a C# program starts execution, the main thread is automatically created. The threads created using the thread class are called the child threads of the main thread. You can access a thread using the current thread property of the thread class. When the code is compiled and executed, it produces the following result. In C#, the system.threading, thread class is used for working with threads. It allows creating and accessing individual threads in a multi-threaded application. The first thread to be executed in a process is called the main thread. Creating threads. When the code is compiled and executed, it produces the following result. Threads are created by extending the thread class. The extended thread class then calls the start method to begin the child thread execution. Managing threads. The thread class provides various methods for managing threads. The following example demonstrates the use of a sleep method for making a thread pause for a specific period of time. When the code is compiled and executed, it produces the following result. Destroying threads. The abort method is used for destroying threads. The runtime aborts the thread by throwing a thread abort exception. Exception cannot be caught. The control is sent to the finally block, if any. When the code is compiled and executed, it produces the following result. Networking and sockets. C# language has access to an entire suite of networking libraries. Some of the capabilities range from low-level socket connections to wrapped HTTP classes. Implementing sockets, a socket server, a socket client, working with HTTP, performing FTP file transfers, sending SMTP mail. This server program instantiates a list string talk and initializes it with quote strings during constructor processing. The real action for this program starts in the main method. Socket operations are encapsulated in the TCP classes. This program uses the TCP listener class to create a socket connection on the local host. The example accepts a single parameter indicating the port number. After the TCP listener class is instantiated, it must be started with the start method. The client program uses sockets to request information from a server. It makes a socket connection, sends a request, and receives a reply. Working with HTTP. HTTP is what enables communication across the web. Knowing how to request a web page can be useful for caching or screen scraping, which is a good application of regular expressions. The create method accepts a string representation of an URL. Here's the statement. After an HTTP web request object is created, it can be used to obtain an HTTP web response object. This happens by invoking its getResponse method, which returns a web response object. The web response object is an abstract base class of the HTTP web response class, and a cast operation is necessary for conversion. Performing FTP file transfers. Another Internet protocol for moving files around is FTP, which is supported by the .NET. FCL, the following sections show you how to get and put files with FTP. Putting files on an FTP server. To upload files to an FTP server, you need to create an FTP request object, get a stream reference to where you want to put the file, and write the file to the stream. Getting files from an FTP server. To get a file from an FTP server, you need to create the FTP web request, open the stream to the file, read the bytes, open the stream to the file you need to create, and write the bytes to the new file. FTP servers require some type of credentials, even if it's anonymous access with a username anonymous and a password that consists of your email address. The rest of the code uses using statements to open the response system, read the bytes from the FTP server, open a file stream to the new file, and then write those bytes to the new file. Remember that the using statements are essential because they close the file streams for you. Data handling logic. Customizing insert, update, and delete with partial methods. Customizing property changes with partial methods. Extend the logic of your system by providing an implementation for any of these partial methods. The following example shows how to detect a property change for the position property of the hospital staff entry. Standard query operators. The following sections provide a quick overview of available query operators, some with C# aliases and others without. Sorting operators. Sorting operations affect the ordering of the results. Order by sets sort order. Order by descending sorts in descending order, then by subsequent sorts, then by descending subsequent sets in descending order, reverse reverses results. You've already seen order by and descending operators used with C# syntax earlier in these sessions. The following example shows how to use a reverse operator. Set operators. Set operators are for set-based operations. Distinct returns unique value. Except, like a SQL left join returns results from one set that aren't another. Intersect returns common elements from each set. Union returns all objects from both sets. Filtering operators. Filtering operators return a subset of a collection of type objects of the specified type, where objects meeting the specified predicate. The C# where clause aliases the where operator, but there isn't an alias for the of-type operator. You could give where a predicate such as where. Projection operators. Projection operators alter the shape of query results. If a projector operator alters the shape, a projection, the results may contain more or fewer fields or perform some manipulation of an existing field from the result set. Select defines the fields or properties to return. Select many flattens a multi-level hierarchy to access results. Partitioning operators. Partitioning operators to specify which group of records you want from a collection. Skip skips over a specified number of records. Skip while skips over records while the specified condition is true. Take takes the specified number of records. Take while takes records while the specified condition is true. A common scenario for the partitioning operators is to facilitate paging. In many cases, the number of records in the record set is too large to hold in memory, so you want to bring in only the minimum number necessary. Here's an example of paging using skip and take. Join operators. Join operators enable you to combine sets of data. Join returns set of records where keys in two sets are equal. Group join builds a hierarchy of objects based on child record set keys that match a parent key. Here's an example of a group join so that you can see the operator syntax. Grouping operators. A grouping operator allows you to create groups of data. Group by returns set of records where keys in two sets are equal. To look up creates a lookup dictionary of lists with specified key. Equality operators. There's only one equality operator which tells you whether two collections are equal. Sequence equal returns true if two collections are equal. Element operators. To return just one record from a collection, you can use an element operator. Element at returns the element at a specified position. Element at or default, same as element at but returns the default value of type if not found. First returns the first element in results. First or default, same as first but returns the default value of type if not found. Last returns the last element in results. Last or default, same as last but returns the default value of type if not found. Single returns the only element in results. Single or default, same as single but returns the default value of type if not found. Each element operator has a version that returns a default value. The difference is that if you invoke an element operator that isn't a default version and the collection doesn't have that value, you will get an invalid operation exception. Conversion operators. A conversion operator allows you to transform results from one type of collection to another. As enumerable converts to interface enumerable type. As queryable converts to interface queryable type. Cast converts weakly typed collection. Of type filters collection based on type. To array converts to an array. To dictionary converts to a dictionary. To list converts to a list. To lookup converts to a lookup. Concatenation operator. There is one concatenation operator and it allows you to concatenate one collection to another. Concat concatenates one collection to another to form a single collection. Aggregate operators. An aggregate operator will perform a computation on a group of values and provide a single result. Aggregate creates a custom aggregation. Average returns an average. Count returns the number of items in a collection of size int.max or less. Long count returns the number of items in a large collection up to size long.max. Max returns the max item. Min returns the minimum item. Sum returns the sum of all items. Windows Forms fundamentals. To get started, create a new Windows Forms application named WinForm Fundamentals. You can do this in VS 2008 by creating a new project and selecting Windows Forms application, or right-click an existing solution file and select Windows Forms application. The results are that you have a new project with references to system.windows.forms.dll. This is a library which holds a Windows Forms API application programming interface. A form is a class just like any other type you write C# code against. All controls on the form are also classes, and you use them just like any other type in C#. Windows Forms is a classic example of the effective implementation and use of delegates and events. You have the Windows Forms API that belongs to the .NET Framework class library that exposes events. Then you use the delegates that those events are based on to connect your code to the API to make your program work. Support for Windows Forms. The visual design environment, files in a Windows Forms application, the Windows Forms entry point, user code, Visual Designer generated code, modifying the Visual Designer, using Windows Forms controls. The visual design environment. Visual Studio has a helpful visual design environment that helps you build user interfaces, which contains controls that you can drag and drop onto the design surface. The design surface is in the middle of the screen. You can see that it is what you see is what you get. WYSIWYG environment, where you can resize the form and visually see the results of your work. Although not shown in this example, non-visual control appears below the form in the Visual Designer in an area called Component Tray. You've seen the Solution Explorer already when building console applications, and it is a necessary part of every application. The Properties window is context-sensitive. It will change depending on which window or control that is selected on the design surface. In such cases, you must use the drop-down window at the top of the Properties window to select the control. Files in a Windows Form application. There are a few different files that were created by the Windows Application Project Wizard. Form1.cs, user code for working with the form. You normally work in this file most of the time. All your event handlers and code that you call your business logic are added here. Form1.designer.cs, Visual Designer generated code. You normally don't ever need to open this file. If you need to write your own code to work with the form, it will typically be done through form1.cs. Form1.resx, resource file for bitmaps, strings, icons, and so on, localizing and globalization, discusses resource files in greater depth. Program.cs contains a main method. The Windows Forms entry point. If you open the program.cs file, you will see a main method. This is much like you've seen in console applications, whose entry point is also the main method. The application.run method will start the program and not return until the application closes. User code. When adding specific behavior to Windows Forms application, you would use the form1.cs class the Windows Application Project creates for you. You can see this code by right-clicking either the form in the Visual Designer or form1.cs in Solution Explorer and selecting View Code. But there are a couple of significant observations to make at this point. First, Form1 is a partial class. Visual Designer generated code. Form1.designer.cs holds a matching partial to the Form1 partial class defined in Form1.cs. When this code is compiled, C# combines these two files into a single class definition. Considering that Form1 is a partial class and its constructor calls an initialize component method, the other Form1 partial class explains the definition of the initialize component method. When modifying the Visual Designer, this example will demonstrate to you how the Form1.cs and Form1.designer.cs work together while you're building a UI. Drag and drop a button control onto the design surface. If you want to delete anything that you accidentally drop on the design surface, select the control and press the delete key, or right-click the control and select Delete. Go to the Properties window and set the following properties. You can find height and width under size. Set text Don't Click Me. Set height to 50. Set width to 150. Set name to Nearlit. Using Windows Forms controls. A control is a specialized window with specific features and unique purpose. These are things like button, checkbox, checklist, combo box, data grid view, date timeoker, form, group box, label, link label, list box, list view, etc. Button control that can be clicked to perform some desired action. Checkbox primarily used for displaying a binary state of an object. Clicking the checkbox causes it to toggle between a checked or unchecked state. Checklist, list box with a column of checkboxes. Combo box, a drop-down list of choices that operate similar to the list box. The primary difference is that the combo box is more compact and efficient with screened real estate. The web application model. When writing for the web, you need to understand where code resides and executes. An ASP.NET application is hosted on a web server, which is where C# executable reside, but it renders HTML to clients via browsers such as Internet Explorer, IE. C# web application. In all of this processing, your assemblies which were built with C# stay on the server. When ASP.NET receives a request, it sends it to your code for processing. The great majority of the time, you don't ever have to emit HTML manually because the object-oriented ASP.NET APIs take care of it for you. The most important point to remember is that your C# code runs on the server, not on the browser. Scalability is a property of software that defines how well it can handle an increased workload. Applications that reach a threshold and then crash or slow to a crawl aren't very scalable. You want a scalable application that performs well at the projected peak capacity for your requirements. To add the component. In Solutions Explorer, right-click the project name. On the shortcut menu, click Add and then click Add Component. Add New Item dialog box appears and the component class in the right pane will be selected by default. Accept the default name, Component 1. Click Open. Unless you choose another name for the component, this creates a new file in your project named component1.cs or component1.vb depending on the application language. The component designer opens a design view on component1.cs or component1.vb. Creating the web application project using Visual C#. To create the web form, on the File menu, click New and then click Project. The New Project dialog box appears. In the Project Type pane, click Visual Basic Projects or Visual C# Projects and in the Templates pane, select ASP.NET Web Application. Name your application My Web Form by changing the default name in the location box, such as http://localhost/web application 1 to http://localhost/my web form. Click OK. The application wizard will create the necessary project files, including the following files. Webform1.aspx contains a visual representation of the web form. Webform1.aspx.cs or Webform1.aspx.vb, the code behind file that contains the code for the event handling and other programmatic tasks. To see this file in Solution Explorer, click the Show All Files icon and then expand the Webform1.aspx node. Webform files. Note, if Solution Explorer is not open on the View menu, click Solution Explorer. State management. In C# web application development, the global state management of application is taken care by different methods. Global state with the application is used to hold information common to all these application instances. This is where application state can be used. Here's an example of how to use application state. Holding updatable information cache is to hold information in memory to avoid the overhead of creating or retrieving that information yourself. Holding state for a single request features holds onto the state for an extended period of time. Holding too much information in memory affects the scalability of your application. Issuing cookies is information with a max size of 4K that you can ask users to hold in their browsers. Whenever the browser visits your site, it presents all cookies that your site gave to it. User-specific information with session state, which holds information for a specific user. When the user visits the page, ASP.NET issues a cookie with a session ID. It then manages session state for that user based on the user's session ID. Understanding page state in view state. Page reuse with master pages and custom controls more work than necessary to duplicate this information on each page, especially with ASP.NET, which instead enables you to implement user controls and master pages. Navigation. In C# web application development uses a hyperlink control, but that has a limited navigation. To add menus and other sophisticated controls, like breadcrumbs, to make a site more usable, ASP.NET enables you to do this with menu, tree view, and sitemap path controls. defining site with web.sitemap, navigation with menu control, theming a site, securing a website, data binding. Theming a site. With themes, you can design a set of skins and CSS styles that apply to the entire site. To add a theme, right-click the web project, select Add ASP.NET Folder theme and name it Custom. You can add multiple themes. They must have different names. Creating skins. Add a label control to a page. Right-click the Custom Theme folder, select Add New Item, Skin File, name the file custom.skin, and click the Add button. Open custom.skin, copy the label control from step 1, paste the label control into the custom.skin file. Securing a website. In C# Web Application, select Website, ASP.NET Configuration, a website by selecting File, New, Project, ASP.NET Web Application. ASP.NET Configuration in the Projects menu. Click either the Security link or the Security tab. Click Use the Security Setup wizard. The wizard, which walks you through 7 steps, will open. The first screen is a welcome message. Click Next. ASP.NET enables you to use Windows or ASP.NET Security. To set up a custom database, run this exe file. Check the enabled roles for this website. Check box. Data binding. Data binding on a number of controls, including list view, form view, list box, drop-down list, and others. These controls have a data source property that takes an IEnumerable collection to bind to. Drag and drop a list view control onto the design surface of a web form. From the list view action list, select a new data source in the Choose Data Source area. After a couple of seconds, the data source configuration wizard will appear. You will see several data sources, most binding directly to the data source. Select Object, which is the Object Data Source control, and click the Next button. Select Hospital Manager and click the Next button. If you recall, Hospital Manager is a business object we created in the preceding section. Error handling. C# exception handling. Consider the error handling methods used in programming languages with no built-in exception handling mechanism. Error handling syntax. The basic try-catch block. Finally, blocks. Handling exceptions. Checked and unchecked statements. Conclusion. In this chapter, the user would have learned about C# using libraries and the following in detail. Namespace system, input-output, multithreading, networking and sockets, data handling, Windows forms, C# in web application, error handling.